Okay, ladies and gentlemen, I want to talk about this lab and upcoming labs. First lab is going to be on vectors. So, getting some stuff out of the way here. You can see this is just a plain cardboard box. And I tied some strings. I made a cotter pin out of paper clips. Very inexpensive way. I'm trying to keep costs down, so an inexpensive type of cotter pin. Used a push pin just to start a hole and then pushed my paper clip through, my cotter pin paper clip through the hole to make a loop so that on the back side you can see bent the edges of the paper clip over so it holds. So the first lab will be on vectors. You can consider this to be the x-axis, the y-axis, and the z-axis. Sometimes people use this as the x, the y, and the z, or let's see, x, y, z, x, y, z. Sometimes x will be up. Rarely. I don't see that very often. Most of the time the z, either the y or the z-axis is up. So if this is the z-axis going up, this would be the x-axis going this way and the y-axis going this way. This is your right-handed Cartesian coordinate system. Take your right hand, and if you put it down on the xy plane like this, z goes up. And if the xy plane is here, z is going this way. And if the xy plane is here, z is going this way. Okay. Measure the components of the vectors. So here's a cheap dollar store ruler, calibrated in centimeters. I taped paper on this. You don't have to, by the way. But still, you got to figure out a way to measure the components. And using a grid makes it a lot easier. Of course, when I'm teaching a face-to-face class, I also use this guy. Inexpensive tape measure. Sometimes they're free giveaways like at trade shows and stuff like that. That free giveaway tape measure, I don't know where I put it. Probably fell off the table or something. So you get components. Be sure and measure not only the components but the length, because we want to see if the sum of the square root of the sum of the squares of the components equals the length. We want to see that also. If you don't feel like making cotter pins this time, painter's tape. We will need them later because we're going to make structures eventually. And that leads to the second next week, or the next lab, the second lab. And that is, we'll need weights and measures. So, get yourself a scale. Here's a few scales. This is an electronic kitchen scale I had lying around the kitchen. Your mom, the cook in your family. My son is the cook in his family. And anyway, whoever likes to cook might have one. So you can fill this water bottle up with water, and that's a pretty good weight, up to 2 kilograms worth. The bottle itself weighs, I got 49 grams. You could use, this is a postage scale, 0 to 1 pound. Calibrated in half-ounce increments, not terribly accurate. Also calibrated in grams though. Designed to fold up, so an inexpensive scale. So whatever scale you use that to calibrate all your weights. Of course, you can use fishing weights, washers, nickels work really well. Now here's my thing I carry around my pocket all the time. It was at a trade conference. I got that giveaway. So this weighs a couple grams, and this plastic cup, you can put a string through it. Where's my bottle with the string? There it is. Tie a string around the neck, drill holes in the plastic cup, and have a string on it, similarly. So that gives you an idea how to make weights and measures. A nickel is almost exactly 5 grams, and with a medicine cup like this, you can get real close, 5, 10, 15 grams, and so forth. Okay, so I'm looking for inexpensive ways for you guys to do these labs. And the first one's on vectors, but the next couple are getting your weights and measures done. The next weight and measure we need to worry about is force. And for that, a clothespin spring works really good. Now I pulled one off of a clothespin, like so. Here's the pieces. We can attach this to a beam. And of course, you cut the beam between the spring. So you'd cut the beam right between the spring. So you'd have 1/2. So now you have a more or less solid beam, but of course it's also, it can also measure some deflection. If you take a couple, these are shish kebab skewers you buy at the grocery store. So now, see if I have this right. If I put it on the right side of the leg, these skewers are going along each leg of this clothespin spring. And I'm just going to squeeze the clothespin, which of course is a compressive force. There we go. I need to glue this down so it's easy to see. There, now it's easy to see. You can see how the shish kebab skewers then act as a dial. They follow the line of the spring. Glue a scale on one side, and you can measure force up to like 1 kilogram with relatively reasonable accuracy. And of course, string made out of this, and of course, twine can be used for a lot of other things. Cotter pins out of paper clips. There it is. So to do that, just a little instruction to show you. Bend the paper clip into 2 straight legs. So, I have my pair of needle nose pliers here. Got 2 straight legs. Bend it around the pliers till it looks something like this. Now, of course, these cotter pins will make pin joints on our structures. We need the force sensors to measure forces on our beams, on frames and trusses and things like that, and machines. So we're going to do statics labs inexpensively at home. There we go. Those pliers, vice grips, and we've got another cotter pin here. Release my vice grip. There we go. Come on. There it is. Ta-da. So, that gives you an idea of what's coming up. Of course, I'll post them on the web. Refer back to this video maybe to give you some ideas of how to do things.